Arsenical bronze is an alloy in which arsenic is added to copper as opposed to, or in addition to tin or other constituent metals, to make bronze. The use of arsenic with copper, either as a secondary constituent, or with another component such as tin, results in a stronger final product and better casting behaviour. Since copper ore is often naturally contaminated with arsenic, the term arsenical bronze when used in archaeology is typically only applied to alloys with an arsenic content higher than 1% by weight, in order to distinguish it from potentially accidental additions of arsenic. Although arsenical bronze occurs in the archaeological record across the globe, the earliest artifacts so far known have been found on the Iranian plateau in the 5th millennium BCE. Arsenic is present in a number of copper-containing ores, and therefore some contamination of the copper with arsenic would be unavoidable. However, it is still not entirely clear to what extent arsenic was deliberately added to copper, and how much its use arose simply from its presence in copper ores, that were then treated by smelting to produce the metal. A possible sequence of events in prehistory involves considering the structure of copper ore deposits, which are mostly sulfides. The surface minerals would contain some native copper and oxidized minerals, but much of the copper and other minerals would have been washed further into the ore body, forming a secondary enrichment zone. This includes many minerals such as tin and tite, with their arsenic, copper, and iron. So the surface deposits would be used first, and with some work deeper sulfidic ores would have been uncovered and worked, and it would have been discovered that the material from this level had better properties. This method would result in the production of toxic fumes of arsenic oxide, and the loss of much of the arsenic present in the ores. This method has been demonstrated to work well, with little in the way of dangerous fumes given off during it, because of the reactions together among the different minerals. Furthermore, greater sophistication of metal workers is suggested by Thornton et al. They suggest that iron arsenide was deliberately produced as part of the copper smelting process, to be traded and used to make arsenical bronze elsewhere by addition to molten copper. Artifacts made of arsenical bronze cover the complete spectrum of metal objects, from axes to ornaments. The method of manufacture involved heating the metal in crucibles and casting it into molds made of stone or clay. After solidifying, it would be polished, or in the case of axes and other tools, work hardened, by beating the working edge with a hammer, thinning out the metal and increasing its strength. Finished objects could also be engraved or decorated as appropriate. Whilst arsenic was most likely originally mixed with copper as a result of the ores already containing it, its use probably continued for a number of reasons. Firstly, it acts as a deoxidizer, reacting with oxygen in the hot metal to form arsenic oxides which vaporize from the liquid metal. If a great deal of oxygen is dissolved in liquid copper, when the metal cools, the copper oxide separates out at grain boundaries and greatly reduces the ductility of the resulting object. It can lead to a greater risk of porous castings due to the solution of hydrogen in the molten metal, and its subsequent loss as a bubble. Secondly, it is capable of greater work hardening than is the case with pure copper, so that it performs better when used for cutting or chopping. There is an increase in work hardening capability with increasing percentage of arsenic, and it can be work hardened over a wide range of temperatures without fear of embrittlement. Its improved properties over pure copper can be seen with as little as 0.5 to 2 Wt%, as giving a 10 to 30% improvement in hardness and tensile strength. Thirdly, in the correct percentages, it can contribute a silvery sheen to the article being manufactured. There is evidence of arsenical bronze daggers from the Caucasus and other artifacts from different locations, having an arsenic-rich surface layer which may well have been produced deliberately by ancient craftsmen, and Mexican bells were made of copper with sufficient arsenic to color them silver.